Hello and welcome to this session about serverless and event-driven computing in Microsoft Azure. I'm really looking forward to the next 45 minutes to cover this topic together with you, and I say a warm welcome to all people who are joining this session online and a warm welcome to all the people who are sitting in the conference room. I am happy to be able to join you, although I'm sitting here in Austria, and let me take this opportunity just to introduce myself. My name is Stropek. I'm a long-time Azure MVP, so I do a lot of work with Azure. I've been using Azure for over 10 years now, and the topic that I'm going to talk about in the next 45 minutes is a topic that we use on a regular basis in our own company. Before we get right into the topic, let me give you a few housekeeping notes. The people who are inside of the conference room at the conference venue, you have a microphone in your room. So if you have any questions at the end of the session, or if you have an urgent question in the middle of the session, don't hesitate to go to the microphone and ask your question. The technicians have told me that I will hear you. Hopefully that will work, and then I will do my best to answer your question. The next one is I will show some demo code throughout this session, and you can find this demo code on GitHub. The link is also part of my slides, and Software and Support Media will provide all the slides, but if you want to have the demo code immediately, here is the URL. So if you want to take a photo or if you want to take a screenshot now, here is where you can find the sample code that I'm going to show you. And last but not least, if you want to stay in touch with me, just use this URI. It's very simple. It's Stropek, that's my name, .me. And here at the right lower bottom, you see a lot of buttons where you can connect yourself through Twitter or Facebook, LinkedIn, GitHub, YouTube, whatever you want. This is the easiest way to keep in touch, and I would look forward to your questions after this session. Okay, I promised you a lot of demos and only a few slides. So let me use just a few moments, just a few minutes to talk about the motivation behind why we are using serverless, especially in a cloud like Azure. So I think this picture is very typical. For me, serverless is like electricity. If I ask my little niece, where does electricity come from, she points to the plug, to the socket in the wall and tells me there comes electricity. She doesn't care about all the engineering work that stands behind this socket in the wall to provide the right amount of electricity at the right location at the right time. And this is exactly what serverless in Azure, I think in every cloud, is really all about. You forget about the engineering work that is necessary to provide the necessary IT resources, servers and so on, databases, storage and so on. You just take your code, you compile it, you throw it over the fence to the cloud provider, in our case Microsoft, and they have to do the heavy lifting in terms of infrastructure. And this is exactly what we are going to talk about. I will show you demos that all are based on Microsoft's serverless features. So here you don't care about servers, you don't care about scalability and things like that. Everything is done for you. That's the whole idea of serverless in Azure, and I think in most clouds. But what many people forget is that serverless is more. Serverless are a foundation for building microservices kind of applications. So larger applications consist of many smaller services, and these services are connected to each other. And there we have an important concept that, especially in Azure, we have to always keep in mind when talking about serverless. Because if you do serverless in Azure, you're also doing reactive programming. Reactive programming means that you reduce the number of simple function calls, and your microservices are coordinated by, for instance, sending messages, by sending HTTP requests and responses. So you have a loosely coupled combination of microservices, and they react on various different events. And I will show you a large number of different event types, and you will see how Azure combines the idea of reactive programming with the idea of serverless computing. The whole goal of all this is It should allow you as the application developer to focus on what's really important, and that's your application logic. It should no longer be necessary to worry about scalability, to worry about providing the servers and deploying patches and things like that. Focus is really the core idea of what serverless in Azure is all about. Do we have drawbacks too? Are there arguments against serverless in Azure? Well, there are. First, you have to trust Microsoft, because serverless means that you have less to do. You have less control. You're giving up control. On the other hand, you don't have so much work. You can focus on your functionality. But you have to trust Microsoft that they will scale properly, that they will be able to provide IT resources just like you trust your electricity provider to provide the right amount of electricity at the right time at the right location. So if you don't trust your cloud provider, never use something like Azure Functions or Serverless. In my case, I'm trusting Microsoft. I'm using Azure for 10 years now, but you have to have trust in your serverless provider. That's important. Many people forget that. And the second thing is, serverless functionality like Azure Functions, what I will show you here, are built for the typical application scenarios, the typical business applications. If you have very specific needs, if you need a super high I/O rate for SSDs connected to your VM because you have a very edgy application that is doing a lot of I/O operations and you have to fine-tune it to the last optimum piece so that you get the best performance for your specific use case, then maybe serverless is not the right application for you. Serverless or platform. Serverless is great for the typical application. If you need very specific things, you might need to go downwards. You might need to use platform as a service or even go down to infrastructure as a service and configure the virtual machines very specifically tuned for your specific business case. And with that, I am done with the introduction, and we will, for the remaining 35 minutes approximately, we will dive right into demos and I will show you everything live. I have no more slides, just as promised. The first thing that I would like to show you is, let's say, kind of hello world. So we are getting warmed up if you want. Let's create a new so-called serverless function, and in Azure, this is called a function app. Here you see a function app. A function app is a container which can host your code written in various languages. I will use C# and .NET as promised in this session, but you can also use different other languages. For instance, if you are more into TypeScript and Node.js, feel free to use TypeScript and Node.js to build your serverless function apps in Azure. Let's create a new one because that gives us this nice little dialog where we can learn a little bit about the configuration possibilities. First, we have to give our function a name, serverless conf life, for instance. Let's see if this name is available. Yes, it is. What you get if you use serverless functions in Azure, you will immediately get a URI with an SSL certificate. If you ask yourself, can I add a custom domain name with my own SSL certs? Of course you can. You can do that, but I will not focus on that in this demo. But this is something that Microsoft gives us out of the box. And then we immediately see the next important options. We can, oops, sorry, that was not nice drawing. Let's repeat that. Here we are. You can decide whether you want to provide your code or whether you want to provide a ready-made Docker container. If your whole workflow works based on Docker containers, you can put your Azure function into a Docker container, Docker image, and then just tell Azure Functions, the serverless runtime, to not worry about the details, to just take the Docker image and run it, and this will be your Azure function. If we stick on code, you will see the currently supported platforms for writing serverless functions in Azure. So we can choose between .NET Core, Node.js, Python, Java, and PowerShell Core. PowerShell Core is the platform independent version. Let's take .NET, and here you can choose between a version. We'll use the latest one, 3.1, and we can choose a data center where we want to run these serverless functions. Let's click on Next. Let's click on Hosting, because this is especially interesting. We need a storage account. Storage account is just a place where Azure Functions can store some binary large objects, blobs, some semi-structured data, a NoSQL database, so-called table storage. Not very interesting. It's managed by Function Apps, by Azure itself. It just needs one, so let's just create a new storage account. We don't worry a lot about this one. It's fully managed by Azure. But now comes another very interesting combination of settings. First one is operating systems. If you ask yourself whether you can only use Windows because it's called Microsoft Azure, that's not the case anymore. For years, Microsoft invests heavily in very good Linux support in Azure. So therefore, you can now choose between Linux and Windows, depending on which operating system you want to use in the backend. To be honest, if you use a platform like .NET Core or Node.js, these are the two platforms that I have a lot of experience with, it doesn't really matter a lot whether you use Windows or Linux. In many use cases, it simply works on both platforms. Of course, from project to project, there are some subtle differences, and some things are supported here and fully supported there. So definitely you have to check out the small print in the documentation, but in general, you can just pick what is suitable for your application. And then we have one of the most important settings here when creating an Azure Serverless function. We can choose the so-called plan type, and this is very Azure specific. I assume that some of you have already some experience with serverless computing in maybe different cloud vendor platforms, and this plan type is specific to Azure, and we have to talk a little bit about it. We have essentially three options. We have the option App Service Plan down here, we have the option Consumption, and we have the option Premium. So what is what? When do you choose which one? Let's start with from the bottom to the top. App Service Plan. App Service Plan is a setting that means that you are consciously not using serverless, but just platform as a service. App Service Plan is not serverless. What do I mean with that? With App Service Plan, you do not get fully auto-scaling, auto-configured out of the box. With App Service Plan, you are in more control. You can still use all the functionality that I will show you in a few minutes in terms of programming model. But you are not opting into serverless. App Service Plan means that you define how many servers you want in your cluster, you define how large these servers are, and you can tune the auto-scaling rules so that they fit exactly what you need. So App Service Plan is the option that you choose if you do not want to hand over control fully to Microsoft, but you want to really control the scaling for your app. Okay? This is the first one. Typically, with Azure Functions, you do not use App Service Plan. You only use that for very specific use cases. The thing that you typically use with Azure Functions is this one, Consumption Serverless. Consumption Serverless means that you tell Microsoft, hey, I don't want to care about servers at all. Here is my code, or here is my Docker image. Run it and scale it for me. The beautiful thing with consumption is that Microsoft will scale it down to 0 if necessary. So if you use consumption, and nobody is currently interested in your, let's say, web API or something like this, you don't pay anything. So consumption scales between 0 instances and a lot of instances. That is what consumption and serverless is all about. But there is a small but here. Scaling down to 0 means that if Azure has scaled down to 0 because there has been no traffic for, let's say, an hour or two, then the first request, if it is for instance an HTTP triggered function, the first request takes a little while because Azure has to dynamically deploy a new instance backing the load balancer sitting in front of your Azure function so that the request can be fulfilled. And that takes a while. That can take maybe a few milliseconds, maybe a few seconds, maybe a lot of seconds, depending on your app, depending on the startup performance of your app. And here, Premium comes in. Premium is, let's put it this way, the best of both worlds. Premium gives you a minimum amount, a configurable amount of pre-warmed instances. So you are not scaling down to 0, but you are maybe scaling down to 1 server or 2 servers or something like this. So you will never have the problem that the application goes away completely and it takes a lot of time until it comes up. Premium will give you good performance at all times. But when you get a burst of requests, for instance, then you have the possibility and the beauty of serverless, because Azure will scale up to a maximum amount of servers that you define. So Premium is a kind of mixture between App Service Plan, where you are in control, and Consumption Serverless, where you trust Microsoft and you allow Microsoft to scale down to 0. Of course, it's also a question of costs. Serverless does cost you nothing if you don't have traffic on your app. With Premium, you have to always pay a little bit of fixed amount of money because it will always be available. So this is one of the first questions that you have to ask yourself if you want to use serverless event-driven functions in Azure. Do I want to go all serverless? Do I want to have control app service plan? Or do I want to have something in the middle which is called Premium? Okay? So in our case, I will demonstrate serverless because it's such a beautiful setting here. I don't have to care about anything. I will not talk about application insights in this talk. And with that, we can create our function app. That's essentially it. If you ask yourself, well, Rainer, this is not the DevOps style that I'm used to work with. Can I create this function app in a kind of scripted way with so-called ARM templates, Azure Resource Manager templates, or PowerShell or Bash so that I can automate everything, even the creation of my serverless function environment? Of course you can. Azure functions can be created based on Azure CLI, which can be used in Bash scripts, for instance. It's fully supported in PowerShell, so you can deploy your function apps and configure your function apps automatically using PowerShell on Windows or on Linux. And you can also use Azure's native so-called ARM templates, Azure Resource Manager templates, which are a kind of declarative way of telling Microsoft what you need. And these are essentially JSON files where you specify, I need a function app with these and these and these and these settings, and that's it. Then Azure will deploy everything for you. So yes, kind of DevOps style, automating everything is fully supported here. And as you can see, it's currently deploying. And in a few seconds, typically it takes, I don't know, 30 seconds, 60 seconds, something like this. Yeah, the deployment is complete. Let's take a quick look in this created Azure Function app and let's see what we can configure here. I will not go into the details because I only have 45 minutes and I would like to show you the programming model of Azure Functions too. So let's just spend a few minutes here. First, if you are not familiar with this one, this is the Azure Portal. It's the UI version of maintaining your whole Azure infrastructure. As I mentioned, you can do all the things that I show you here in PowerShell or the CLI or ARM templates. The first one is here, functions. You will see a list of functions. Now, currently, there are no functions. If we want to add one, we just hit add, and then we can immediately create a function interactively, directly here in the browser window. It will even give us a programming environment, a very, very lightweight programming environment where we can type in the code directly here in the portal. To be honest, that is nice for hello world demos, but that is not how real developers work with this stuff. So this is just hello world, and I will not spend time with that because in practice you will rarely do that. Typically you develop locally, this one, I will show you that in a second, and then you deploy using a continuous integration and deployment pipeline like GitHub Actions or Azure DevOps Pipeline, something like this. This is the real way of working with Azure Functions. But if you just want to play around, feel free after this session to go here to add and play around with your favorite programming language. Type the code in directly here in the browser. It will just work. App keys. App keys is something that I have to describe quickly. Microsoft is aware of that security is really a hard thing. If you ask yourself, well, can I use all the nice standards like OAuth 2 or OpenID Connect and so on? Yes, you can do that, but it requires a lot of knowledge about security, authentication, authorization. It is built into Azure Functions. Many developers would like to have a more lightweight way of doing authentication. And the most simple way of doing authentication is simply having a shared secret, a so-called function key. And what you can do is you can create keys per function that you can hand out to, for instance, your business partners. That's just a string, and they can pass in that string in the URL or over an HTTP request. And with that, authenticate themselves onto your Azure function. So you do not need to write your own API key management if you want to use simple API keys as your way of authenticating your work. If you want to go all in and do all the crazy OpenID, OAuth stuff, it is supported in Azure Functions, but I cannot cover it in 45 minutes. I'm very sorry. I hope you understand that. That will be a topic of a completely different, a completely separate session. The next one that I would like to show you is these settings here. Here you can say, okay, I want to do authentication. This is the OpenID or stuff that I already mentioned. I want to do logging, telemetry, and things like that. In Azure, this is called Application Insights. I will not go into the details because I only have 45 minutes. But if you want to have detailed logging for having a kind of X-ray system built into your whole system, into Azure Functions, then you should definitely take a look at Application Insights. You can have custom domain names, SSL certs, you can do some networking where you can add your Azure function to your virtual network. You can even turn off public internet access to your Azure function, connect your local area network through a VPN gateway with Azure, and have a complete private environment where you can benefit from the nice things from Azure Functions, where you can have your serverless functions for your internal business apps without having to expose them to the public internet. So this is possible in the networking section. And it comes at a very, very low cost point. The key that you want to look up here is called private endpoints. So private endpoints make it possible to use serverless functions without connecting them to the public internet. Down here, we have a bunch of development tools and a bunch of monitoring and diagnostic tools, and I will not go into the details here because from now on, for the remaining, let's say 20 minutes or so, 15 minutes I think we have, I would like to switch gears and go a little bit away from the hosting environment that you have seen now onto the programming model. I would like to show you how you can code with serverless functions. And this is where we are leaving the territory of serverless and go into the territory of event-driven computing. Now this sample is built using .NET Core and C#, but the concept is exactly the same in all the programming languages that you have seen before. So if you are not a .NET developer, still try to see the concepts that I show you here, and you will see the same concepts in different programming languages, of course with different syntaxes and so on, but I think you will get the point. In my scenario, I have set up a demo application. I gave you the link to GitHub a few minutes ago, and this sample application processes fictitious, let's say, car traffic monitoring cameras. So if we have a car driving on the highway, we have some fictitious cameras taking pictures, then we do a license plate recognition, and then we do things like vignette checking. Is the car allowed to drive on this hardware? We do things like section control. Isn't the car too fast? Things like that. That's the whole idea. Let's get started with this function here. We don't care about the implementation. We only care about the declaration of the function here on top, because here we can find the event-driven and serverless pieces which are really important for this session. The rest of the implementation, it's just C# code and just other Azure services that we do not really care about in the moment. The first thing that I would like to talk about is this one. Every Azure function has a trigger. And you have a large amount of triggers that can trigger your function. That is meant with event-driven computing. This is the event triggering your function. In my case, just to make it a little bit more interesting, it's not a simple HTTP request. By the way, you see an HTTP trigger down here, but we will leave that out for the moment. In my case, I'm using a blob trigger here. So if a camera creates a picture in a certain blob storage, you see it here, we want to trigger our function. And you have a lot of other triggers. You have triggers for messaging systems, for instance. You have an AMQP compatible messaging system in Azure where you can react on incoming messages. We have high performance eventing system, which is called Event Grid. There is an eventing system for IoT scenarios, which you can use. It's called IoT Hub or Event Hub that you can also use to trigger your functions, for instance. There are many triggers, and I would invite you to go into the Microsoft documentation to see all the triggers which are available. I will mention some of them here. So as you can see here, we do not have to write any code to do a kind of polling loop or register for events in a system. We just write, hey, trigger this function whenever a blob is created, whenever an HTTP request comes in, whenever a message comes in, whenever an IoT device sends a message. This is how we do the triggering of the function. The next thing is this one here. We can pass on control to the next functions by returning some things. And in this case, we use an output binding. This is called an output binding to service bus. This is a messaging system. So in my case, my functionality here is I take the image, I trigger a license plate recognition. I'm using an AI license plate recognition service in the cloud here. You can take a look at the code in GitHub if you want. And once we have recognized the license plate, we will return a message, and we do not have to care for manually writing the code to get a reference to the service bus, to the topic subscription here, to the topic in this case, to send a message. We just return a message. And the programming model of Azure Functions will do all the heavy lifting of getting the reference to the service bus, adding the message to the topic, and delivering the topic to all the subscriptions. And of course, the subscribers can again be functions. So here you see the analogy to the picture that I showed you later on. We have one function after the other, and they are loosely coupled using mechanisms like, for instance, messaging systems. Okay? So let's take a little bit of a look here into our code. We get a so-called cloud block blob. This is the image that the camera has uploaded. And let's take a look at the service bus here. If I go down just to show you an example, here is a helper method that I created to create the message that should be sent. And if I go down, you will see that all we have to do is we have to create a message, but sending the message is not up to us. This is done by the Azure Functions runtime. This is the event-driven stuff that I'm talking about. Okay? So let's take a look at the next function, which will be triggered when we send the message through the service bus. For instance, check vignette. Let's take a look at the differences here in our implementation. Oops, let me get rid of this one. Now it's getting better. Here you see a different Azure function. This time we are not using a blob trigger, but we are declaratively telling the system, hey, trigger this function when we get a message in a certain subscription in service bus. So we just define a service bus trigger. And then in this case, I decided to not go here with a return statement, but I decided to use a different programming model, the so-called Ias and Collector. This is used if we want to return not just a single item, just like a single message that should be sent, but with Ias and Connector we can send multiple output messages. And here I added a very interesting one. I added for you a signal R output binding. Signal R, for those of you who are not familiar with this protocol, it is a protocol which sends messages over WebSockets. So with Signal R, we can use WebSockets to serverlessly send messages through WebSockets back to a browser client, so the backend can trigger, for instance, in JavaScript functionality in the browser client to inform the browser client that our serverless function event-driven stuff has done something interesting which should be presented to the user in the UI. Yeah? This is the kind of events with triggers and outputs and so on that you can use here. I added Signal R to make it clear that event-driven computing in Azure is not just about backend. It's connected with the front end using WebSockets and the Signal R protocol. And with that, we can do event-driven computing across tiers, from client to server, from server to client, without having any poll messaging, without having any polling or something like this. So maybe you are interested in how this application really works, so let me demo it real quickly. I will run it here locally. So I will run it here in my Visual Studio. And that is also one thing that I wanted to show you, because many people let me quickly set a breakpoint here. Let's set the breakpoint here. Many people hesitate from using serverless functionality, serverless programming models, because they think the programming is hard and it's not the typical debugging experience that you are used to when writing applications. This is not true for Azure Functions. If you use Visual Studio or Visual Studio Code, everything is running inside during development. Everything is running inside the local Azure Function tooling. The Azure Function tooling sets up a complete runtime environment on your local computer. Can be Windows, can be Linux, can be Mac. And you can test your functions. You can set breakpoints. You can debug everything until everything works as expected. And only if it works as expected, you take your app, you put it either in a Docker image, or you put it in a zip file in an archive, and you upload it to Azure Functions really in the cloud. And then everything is running in the cloud, and you no longer have a local environment running for debugging purposes. But I think for demo here, it's nice to see that debugging works as expected. So let me quickly show you here the Storage Explorer, because I told you that in my case I am using a simulated, let's say, traffic camera. And let me show you the image that I'm going to use here. Of course, I needed a nice little car here, and I'm using a DeLorean from Back to the Future. And please remember this license plate here. This license plate will be recognized by my AI license plate service in the cloud. So let's simulate the traffic camera by copying this image to here. It's going uploaded, and see, Visual Studio now hit the breakpoint because through the blob trigger, my processing of the picture was triggered appropriately. Now, we know that we will have a license plate, a UI with Signal R, and I run this UI here locally at port 4200. You see, no messages yet. Let me quickly show you the client code, just that you see that it's really, really simple. This is the TypeScript code, and I have kept it as simple as possible to demonstrate the point that even working event-driven way down to the client is really, really simple. You see it here. The only thing that I do here in JavaScript and TypeScript is I'm setting up, of course, because everything is debugged locally, a connection, a Signal R connection, WebSockets, using localhost. In real world, this would be an URL in Azure. I'm saying if we recognize a vignette violation, then we just push it on the UI. So if everything works out nicely, it shouldn't be necessary to refresh the UI, but just because of the event-driven stuff and the Signal R stuff, the events are not only flowing in the backend, but they are also flowing to the client. Let's see if it works. Let's go into the check vignette here, because this is the first step in our flow of messages. Remember, this one is triggered by the blob storage. we are returning something to the service bus which sends a message through a topic to a subscription. And this message should then trigger a different, let's say, microservice, which is doing the vignette checking. Is the car allowed to drive on the highway? And then, if we have a violation, I'm adding a message to SignalR, and this should send the message to the web browser client. For instance, this could be the monitor of an operator checking if everything is okay, and he wants to have a push notification that something strange is going on. So let's continue. Next thing, our check vignette function should be triggered. Takes only a second. Oh, I stopped it. I'm sorry. I didn't want to stop the application, but I stopped the debugger. Yep, sorry. So now let's get started again. Good, it comes up. Good. Let's refresh our UI. Good. And let's upload another image. There it is. That should hit our first breakpoint, just as I showed you before. Here is the breakpoint. Let's continue. This triggered our check vignette, exactly as I promised. And now let's continue and go to our browser. And you see, we already got the vignette violation. And I can demo that even more clearly. If I, for instance, take this image again and upload it, I will do nothing. Everything is running in the background. Breakpoint, continue, continue, and as you can see, next violation appeared. So this was what I wanted to show you. I wanted to show you that the programming model is also part of serverless functions in Azure. It's not just not caring about scalability, not caring about servers, not caring about updates, because that is done by Azure. But Azure Functions is also a programming model that makes it rather simple, or let's say simpler, to build event-driven applications, maybe designed in a kind of microservice style, but not just in the backend, but also doing serverless push notifications down to the client, which can be a browser client, a Java client, a C# client, whatever you have in your scenario. That was my demo. And that brings me back to my last slide, and then I will open it up for the remaining, let's say, 5 minutes for questions. I wanted to demonstrate you what serverless means in the Azure platform. It's function apps. Function apps cares for scaling automatically. You don't need to care about the engineering work necessary to provide the right amount of IT infrastructure at the right point in time, at the right location. This is done by Azure. You are just providing the application, just like plugging in a TV, for instance, here into this socket. But the functionality of autoscaling and providing the necessary resources is not enough. It's also a question of programming model, and this is why I added the term event-driven computing to this session, because I wanted to show you that it's not just about scalability, but also about making it simple and easier. Simple. It's still not simple, but making it easier to build event-driven applications that are separated into microservices or even micro UIs. I hope you enjoyed this presentation. 45 minutes are so short, so I had to cut some interesting stuff, but I'm quite sure, based on the knowledge that you gathered here in this session, you will be able to understand the documentation and maybe look up detailed information in the documentation or YouTube videos or whatever. And I would like to open it up for questions. Let me quickly take a look in the, here. There are some questions with Streaming, I'm sorry, this is not my part, so I cannot answer any streaming questions here. Let me quickly take a look in the chat window here. We don't have any questions. So I will give you a moment if you have a question to ask your question. Also, I invite everybody sitting in the conference room to ask your question through the provided microphone. Hi. Yes. That's a very good question. You obviously have some knowledge in Azure, so you know what an app service plan is, and I guess you have used them with, for instance, web apps before. Am I right? Okay, so you have to understand that Azure Functions is built on the existing app services. So Azure Functions is an extension to app services. So if you have already knowledge about Azure App Services, then you have a lot of advantages when you use Azure Functions, because all the configuration that you are used to with app services are present for Functions too. Functions is just the serverless piece adding on top of what you already know. So no, it's not obsolete. It's an extension to what you know from web apps and app service plans. The new thing is the programming model that I showed you, the event-driven programming model, and the new thing is the serverless scaling, which can scale down to 0, which was not possible before Azure Functions saw the light of were invented by Microsoft. I hope that answers your question. You're welcome. Any other question? Well, to be honest, I can't take any questions because any more questions, because I was told that I have to end sharp at 11 a.m. It's now 10:59, and I love it when I covered all my topics and the time is over. Time is over. I hope you enjoyed this session. Have a nice conference. Enjoy the rest of the conference. And if you have any additional questions, don't hesitate to use the conference system or to send me a tweet, an email, or any social media platform that you enjoy. So enjoy the rest of the conference. See you at the next event, and I'm looking forward to your questions and feedback through the various social media platforms. Thank you.